in the tunnel entrance, you need to have a high amount of flux to avoid a dark spot as it's shown. So that's why we have the counterbeam solution, which will aim in the direction of the driver to enhance the visibility at the entrance of the tunnel.
So welcome everyone to this latest Let's Talk Light presentation from Thorn Lighting. In this presentation, we're going to talk about the road to better lighting, introducing the R-PEC Optic System. So my name is Peter Thorns and I'm Head of Strategic Lighting Applications. And my co-presenter is Maxime Perdu, who is an optical engineer and is actually involved in the design of these optics. If you have any questions, you're quite welcome to send us an email and we will respond appropriately and accordingly. This is actually the third talk out of a session, set of 5 sessions. So, as I said, this is on the R-PEC optical system. The next session will be on Zaga, so be ready, be future-proofed, and that will be by Waldemar Becker, who will also present session 5 on UrbaSense, who's looking at outdoor lighting controls. If you've missed sessions 1 and 2, they are available to view still as they were recorded. So to start with, what is R-PEC? Well, we have two versions. We have R-PEC and we have APEC. R-PEC is for road lighting, and for roads and tunnels, we have 24 precision distributions. And we have APEC, which is actually for amenity lighting. But just as much as the difference between the R-PEC and the APEC, it's important to understand the PEC part. So that stands for performance, efficiency, comfort. Effectively, performance, does it do what you need it to do? Does it give you the visibility of the space? Efficiency, does it do it using minimal electricity and using minimal resources and having minimal impact on the environment? Because not only is it important to use less energy, we have to be sustainable and we have to be sensitive to the local ecology. And comfort, does it actually do it in a way that doesn't cause you discomfort while you're driving on the roads or walking down the roads? So this performance, efficiency, comfort is really important. So I'm now going to hand over to Maxime, who will discuss the different options we have within R-PEC and also tell you a little bit about our lighting design software. So over to you, Maxime.
Thank you, Peter. I am Maxime Perdu, the optical engineer who worked in the development for the road lighting solution. What is important here is that we have a powerful software which is fully integrated to SolidWorks, a common industry CAD application, which improves the way we can work with real simulation of product because we consider the complete system while doing the optical development. And this is something we really have an internal development on the sources, on the material characteristics, and also the optical shape that we create. It's all managed internally with our software. And of course, after being produced in simulation, we also have the part to be manufactured and to be controlled to ensure the quality from the lenses in the end of the product is still matching the intended performance. So one word I want to say about LED technology is that it allowed to be more precise in the lighting design. Lighting design either made of lenses or reflector or optical scattering parts. On this because a higher amount of light can be extracted from a single smaller light source. So such a small emitting component can be considered more closer than a point source, and in the optical systems, it allows to be always in focus with less space needed. That's why we can think about increasing the freedom of lighting design, optical design, and thus to reach a better quality in the shape of the lens we produce. So in the next slide, I will be showing the lens system we called R-PEC that we produced in the way we can address the different application that was previously mentioned by Daniel Pars in the previous talk. And our R-PEC system has been developed for many applications. And the first one would be major and minor roads. On such traffic road, the safest way to enlighten the street is to consider the luminance, because indeed what is really perceived by a person, and when we design a lighting scenario or an optical part, we have to keep in mind that the luminance is what is perceived by the eye. So we have to take his position compared to the lighting system into account. We can quickly summarize that the eye perceives luminance. So it implies that the light which is reflected by the road needs to be taken into account in the design process. Let's have a look on the chart, the graphic in the right-hand side. You can see there are two sources of luminance. The first one, which consists of the light which is reflected by the road in the direction of the driver. This light should be maximized on the most uniform as possible, and also bright enough to match the lighting requirement. The second source of luminance is the direct light from the luminaire in the direction of the driver, which should be minimized even if the driver is not looking at the luminaire itself. It could be a source of glare. And both these parameters are interlinked. At a certain point, it's improving the first parameter, the light reflected in the road, will affect the second parameter and make it less optimized. You will improve the glare of the solution. So that's why in R-PEC system we made optic in order to ensure compliance to the lighting standard, and also to have a choice between the optimization of the luminance uniformity and performances, or to choose to optimize the lowest glare as possible. That's what we call the comfort of the R-PEC. And here we have a bunch of optics that are shown in the screen. It shows that you can select either luminance for uniformity in the left column, or more comfort or more specific application, because what we can see is the surface road is really matters to the lighting calculation, and we can even consider wet road surface to have the best lighting result, the closest to the reality. So in this slide, here there are two examples of lighting calculation we can make. It illustrates a difference between the optics I mentioned before. The first one would be the one in the right, which is a linear section we can simulate with the lighting reality software, and it shows that the uniformity from each point of the road of the standard grid can be calculated with the optic. And of course, Thorns lighting provide fully measured product to do this estimation. But in development, I made it for every single lenses in simulation to ensure that the performance is achieved. This linear section shows that it's rather a wide installation, so we had to use the WR optic in our range, but it also, the most limiting criteria was the glare rating. So we had to choose an optic which is compromised for the comfort and less for the uniformity, but still it achieves the best result that we could find in this calculation. The second case is also a very interesting one. It can give a quick overview of what happens if the surface of the road goes wet. We have in the left a very optimized optic for all dry conditions from our range. And you can see if the surface goes wet, it gets even more closer to a mirror, so it creates dark spot because the light is not reflected in the direction of the driver anymore. And we have to develop optic in anticipation if the road goes wet. This requirement is mostly used in Nordic countries of Europe, and if it has not been taken into account during the development, there is a very little chance that standard normal optic can comply to this lighting calculation. Then I will go with the next type of roads, which are the residential street roads, and it's in this case not relevant to have the driver position to make all the calculation, because the people can come from anywhere in the place, from corner houses, pedestrian paths, and we simply need to provide the best lighting as possible in the area. It means that we have to stick to uniformity values, which must be maximized, and we also want to minimize the intrusive light. We want the maximum amount of light from the luminaire to the relevant area on the ground. It is what we call the utilization factor. To have a good utilization factor, it's important to have different cutoff angle of our optics to be always to always correspond to the dimension of the streets. And of course, there is a great variety of road dimension, so that's why we have also a lot of optic in our range that can comply to different geometrical lighting calculation. For example, what is easy to make is the ratio between the height of the pole and the width of the street. It can give a quick overview of which optic from our range is the best candidate to improve the uniformity and also to maximize the utilization factor. In the right of this slide, you can also see that complete district can also be calculated. And in this case, you have every different scenario as possible, and some extra wide optic can address dark spot in dead ends for this example. So it's important to have a great diversity of optical distribution in order to address the best way as possible the size of the road. Next, I will discuss a bit conflict area and pedestrian crossing, which is the same type of lighting calculation, but we only increase the flux on the uniformity acceptance. So it should be done to allow the best view of the scene. You need to have a bright area where you can have the conflict between pedestrian and drivers, but also a good uniformity over all the place. That's why both these criteria have been taken into account to develop our optic. I selected 3 of our widest optic that can achieve the best overall uniformity for the lighting calculation, but also I'd like to mention that for pedestrian crossing, it's a different type of calculation, and we made a double asymmetrical optic aiming directly in the direction of the pedestrian, which should be enlightened both in horizontal and vertical way as best as possible to create a good view of the hazard, the possible hazard, and to avoid it. And last, I want to say a word about tunnel lighting because it's also a type of calculation that we made in our range. You have a room where it's different than luminaire on poles because rows of products can be in line and you can have more product than in the street, but also the expectation of uniformity and performance are a bit higher than in the street because it's important to enlighten the tunnel as best as possible. In the left, you can see that in the tunnel entrance, you need to have a high amount of flux to avoid a dark spot as it's shown. So that's why we have the counter beam solution, which will aim in the direction of the driver to enhance the visibility at the entrance of the tunnel. In addition, we also made symmetrical optics for the interior section of the tunnel, which are symmetrical. It means that there is the same amount of flux in frontward direction and in backward direction, but also in left and right direction. That's why we could develop complete product addressing also all type of tunnel on every number of lane in a tunnel. And that's it for the technical description of the range. I will let the end to Peter again, and thank you for listening.
So thank you, Maxime. Here you can see on this slide a table that shows the entire range of the optics that we have, but this is done in terms of application. So you can see along the x-axis the road classification, whether it's an M-class road, a P-class road. As Maxime mentioned, we have optics that are specific for wet conditions, places that you expect to be wet a lot, such as bridges. We can light pedestrian crossings and also tunnels. Going up the y-axis, you can see we have this factor, which is the height divided by the width. Now, the height is relatively straightforward. It's the height of the actual luminaire above the road surface. The width, you have to think about the geometry of your space. So if you have your luminaire that is actually on the edge of the road surface, that's quite straightforward. Your width is the width of the road surface. If your luminaire is set back from the road surface, so in this example that we show, it's set back by the pavement width, then you have to take that into account. So in this case, we have the road width of 8.5 meters, but we have to add the pavement width of 2 meters plus 2 meters because it's on both sides. Therefore, we end up with an actual W factor of 12.5 meters. So you have to look at the geometry of your space, understand where your luminaire is actually going to be in that space, and that will tell you what your width will be. But once you have the width, you can read up the y-axis, find out where you come on this factor, and then read across the x-axis and understand what your application is, and this will tell you the best optic for that space. So R-PEC may sound complicated, but actually it's quite easy to apply just using this table. So thank you for listening. I hope you found it interesting and informative. If you have any questions, please feel free to email either myself or Maxime. You can see our emails on the screen now. And don't forget that we have 2 more sessions to go, and please feel free to register and listen into them. So thank you very much and take care.